For 70 years, we have built machines that think in a straight line, faster and faster, one step at a time. But there are problems so massive, so complex, that even the fastest supercomputer on Earth would take 1 billion years to solve them. We have hit a wall. To break through that wall, we can't just build a faster machine. We have to build a different kind of machine. One that doesn't just calculate, it dreams. It explores every possibility at the exact same time. To do this, we must leave our world behind and build an engine in a realm of pure impossibility. A machine that operates at a temperature of deep space. A machine that can solve in seconds what would take our greatest computers an eternity. This is not science fiction. This is the next evolution of computation. The age of the quantum leap. You are about to witness the dawn of a new technological reality. If you are ready to understand the impossible, subscribe now. The journey into the quantum realm begins. At the heart of every computer, every phone, every device you own are billions of tiny switches. Bits. A bit can only be one thing, either a 0 or a 1, on or off. It's a simple, undeniable truth. To solve a problem, classical computers string millions of these bits together, performing calculations one step at a time, a logical linear progression. But for truly complex problems like understanding every possible interaction in a single molecule, this linear approach becomes a daunting, almost infinite maze. To escape this maze, we don't need a faster bit. We need a different kind of bit. We need a qubit. Unlike a classical bit, a qubit can be a 0, a 1, or impossibly both at the same time. This is superposition. Imagine a light switch that isn't just on or off, but existing in every single state between on and off, all at once. That's the power of a qubit. This ability allows a single qubit to hold exponentially more information than a classical bit. It's not just exploring one path, it's exploring every path simultaneously. But there's a catch. This quantum magic is fragile. The moment we try to look at a qubit, the magic breaks. The act of measurement forces the qubit to choose. It instantly collapses from its superposition of possibilities into a single definite state, either a 0 or a 1. It's a fundamental paradox. The very act of observing changes reality. We only ever see one outcome, even though the qubit held countless possibilities just moments before. This fragility is the ultimate challenge. How do you harness something so powerful, yet so easily broken? This is where the true quantum journey begins. If superposition is the heart of quantum computing, then entanglement is its impossible nervous system. Imagine two qubits separated by light years. Interact with one, and the other instantly responds no matter the distance. It's an instantaneous, ghostly connection. Even Einstein called it spooky action at a distance. It defies our understanding of how information should travel. These entangled qubits become intrinsically linked. You can't describe one without describing the other. They are two sides of the same quantum coin. This connection is the key to solving problems that are impossible for classical machines. Imagine a vast, complex maze. A classical computer would have to try every single path, one after another, painstakingly searching for the solution. But a quantum computer using superposition can send a wave through the entire maze, exploring every path simultaneously. And through entanglement, these qubits on every path can communicate instantly, sharing information, eliminating dead ends, guiding the entire wave towards the correct solution. Where a classical supercomputer would overheat, strain, and take millions of years to find an answer, the quantum computer, silent and cold, can arrive at the solution with an almost effortless, impossible speed. It doesn't brute force the problem. It experiences the entire problem at once, leveraging the very fabric of reality to find the answer. In the blink of an eye, the impossible becomes solved. This is the promise of quantum power. A qubit in superposition is the most powerful information-bearing object in the universe. It is also the most fragile. The quantum world is shy. Any interaction with our world, a single stray particle of heat, the tiniest vibration, is a catastrophic event. It's called decoherence. The quantum magic shatters, and the immense calculation collapses into meaningless noise. The enemy is chaos itself. To build a quantum computer, you must first solve an impossible problem. How to protect this fragile quantum state from the constant violent storm of the classical universe. The solution is not a computer chip. It is a cathedral, a magnificent golden chandelier that is one of the most sophisticated machines ever built. Its only purpose is to create a perfect sanctuary of absolute cold, pulling heat away, layer by layer, in a journey towards the coldest temperature achievable by man. Colder than the vacuum of deep space, a silent, perfect void where the quantum world can finally breathe. It is a monument to human ingenuity, a mountain of classical engineering, all designed to protect and control a handful of atoms performing their impossible dance. And in this perfect silence, the work begins. To program a quantum computer, you don't write code, you conduct a symphony. Perfectly timed microwave pulses, acting as microscopic chisels, are fired at the qubits, gently nudging them into the precise state of superposition needed for the calculation. It is a ballet of unimaginable precision. Hundreds of these pulses, woven together in a complex algorithm, guiding the quantum state without shattering it. Just to make it run, just to keep the chaos at bay for a few millionths of a second, is a triumph. A victory against the fundamental nature of the universe. So what is the purpose of this impossible machine? Its first gift will be to revolutionize our understanding of life itself. A quantum computer can simulate the complex dance of molecules with perfect accuracy, allowing us to understand diseases as never before. It will be the ultimate design tool, creating new life-saving drugs, not through trial and error, but through pure, precise calculation. It will allow us to forge new materials atom by atom. Superconductors that work at room temperature, hyper-efficient solar cells, the building blocks of a new world. But every new god has a dark side. Our entire digital world, our banking, our governments, our secrets, is protected by a wall of mathematical encryption. For a classical computer, breaking this wall would take trillions of years. For a quantum computer, the lock is not a challenge. It is a simple puzzle. With its ability to see every possibility at once, a mature quantum computer could shatter the locks to every digital vault on Earth. The age of secrets will be over. But its ultimate potential is even grander. A quantum computer could simulate not just a molecule, but a galaxy, perhaps. Even a universe. Will it allow us to finally create a true artificial intelligence? A new form of consciousness, born from the marriage of our ingenuity and the universe's strange quantum laws. In the end, the qubit is a perfect metaphor for our own existence. A fragile, improbable state of being, holding infinite possibilities within it. We have built a machine that operates on the fundamental laws of reality itself. We have captured a piece of the universe's operating system, and what we do with it will define the future of our species.